Hey everybody, Mr. Quick here. Welcome back. Today we're talking about Eureka Math / Engage New York Math Module 1, Lesson 4. We're continuing to talk about equivalent ratios. The previous video, Lesson 3, was a little bit long. I think this one will be a little bit shorter, a little bit faster paced. Today we're going to check and see if what could be equivalent ratios are actually equivalent ratios. Let's dive right into it. Okay, here's a question directly from Eureka Math. The morning announcement said that 2 out of every 7 sixth grade students have overdue library books. Jasmine said, that means 24 of us have late books. Grace argued, that number is too high. How can you figure out who is right? Well, first of all, let's look at the ratio that the morning announcements gave us. They said 2 out of every 7 sixth grade students have overdue library books. So 2 students for every 7 total students have overdue library books. So that's our first ratio. If we're going to look at 24, they said 24 of us have late books. That would mean if 2 students have late books for every 7 students who do not have late books, well, in that case, that would mean 24 students have late books for currently an unknown number of total sixth grade students altogether. So let's take a look at this. We have a ratio here, and we have a part of a ratio here. Now, Eureka Math gives us, let's say, a definition here, and this is what it says. Ratios are equivalent if there is a non-zero number, so it can't be 0, that can be multiplied by both quantities in one ratio, so meaning the 2 and the 7, to equal the corresponding quantities in the second ratio, which would be 24 and currently our unknown number. So let's start off with, some people, you might see it referred to as C, or the constant number, and that's probably more mathematically correct. I've always liked to call it the magic number when I look at equivalence. Just kind of a fun way for me to think about it. All right, so to get from 2 to 24, we have to multiply by 12. 2 times 12 equals 24. If we multiply one of the quantities in the first ratio, we've got to multiply the other quantity. So 2 times 12 is 24. In that case, we'd have to also do 7 times 12, which would be, let's see, 7 times 10 is 70. 7 times 2 is 14. 70 and 14 is 84. Meaning 2 to 7, the ratio 2 to 7, is equivalent to the ratio 24 to 84. And the constant is 12, because we multiplied 2 times 12 to get 24. We multiplied 7 times 12 to get 84. Now, let's go back to that original question. It says for every 2 out of every 7 students have overdue library books. That's how we got the comparison of 2 to 7. And Jasmine said, that means 24 of us have late books. Well, is that correct? Here's the deal. It's hard to say. We would need to know, are there 84 students in 6th grade? If there are 84 students in 6th grade, then this ratio and this ratio being equivalent, that would mean that those numbers are all correct. If, for instance, let's erase that. Let's say there are 87 students in 6th grade. Well, 2 times 12 gives us 24, but 7 times 12 does not give us 87, and that would mean that that number 24 is incorrect. Okay, let's look at some more examples. It says, are the following ratios equivalent? They've given us a ratio of 6 to 11 and 42 to 88. Well, here's how I'm going to write it out. I'm going to say 6 to 11. I'm going to leave a little bit of space for that constant, or as I like to call it, my magic number, what I'm going to multiply by. And then down below, 42 to 88. Okay, 6 times something, we don't know what, is going to be 42, right? Well, if I count, and I'm going to use my fingers here, 6, 12, 18, 24, 30, 36, 42. I just raised 7 fingers. So I know 6 times 7 is 42. That's a math fact. I also could have said, all right, 42 divided by what gives me 6. 42 divided by 7 gives me 6. So my number is 7, my constant or my magic number. 6 times 7 is 42. Now, 11 times 7, does that equal 88? No, I mean, that's an easy one, right? 7 times 11 is 77. So in this case, these two ratios are not, the answer would be no, they are not equivalent. If we were going to make them equivalent, we would have to erase that number and make it 77. If it was 42 to 77, then these two ratios would be equivalent, but they are in fact not equivalent. Let's look at another one. 2 to 5, 8 to 20. And I'm going to leave this space for my magic number, also known as my constant. Well, to get from 2 to 8, I'm going to have to multiply by something. Well, 2, I know it's a math fact, right? 2 times 4 is going to give me 8. 2 times 4 gives me 8. Or if I went the opposite way, I could say 8 divided by 2, and I would get 4, right? So 2 times 4 equals 8. Now, for this to be an equivalent ratio, for these to be equivalent ratios, that would mean that 5 times 4 equals 20. Is 5 times 4 20? It is indeed. So 2/5 are, 2 to 5 is equivalent to 8 to 20. Okay, one more word problem here. This is directly from Eureka Math. You'll be doing some similar problems, and I'm going to read it for you. In a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. So, just because I want to do it, I'm going to say walnuts to cashews, 5 to 6. So for every 5 walnuts, there are 6 cashews, meaning there'd be more cashews in the bag. I write these things down. It helps me as I do the problems. It helps me keep everything straight. Back to the problem. We're right here. Determine the number of walnuts that are in the bag. So we're trying to find the number of walnuts. If there are 54 cashews, use a tape diagram to support your work. Justify your answer by showing what the new ratio you created of the number of walnuts to the number of cashews, that it is in fact equivalent to 5 to 6. Two possible ways we could do this. One, we could look at that magic number, right? 6 to get to 54, well, 54 divided by 6 is 9. Also, I know my math facts going the other way. 6 times 9 is 54, so my magic number would have to be 9. If I do that on one side, I've got to do it to the other number in the ratio. 5 times 9, I know is 45. So 5 to 6 is what they gave us as the ratio. That is equivalent to 45 to 54. So in the bag, there would be 45 walnuts and 54 cashews. Let's look at this one other way, because I want to show you how to use a tape diagram to prove it. Now, either method is valid. I want to make sure that you're able to get to the right answer, but I also want you to have a number of tools in your toolbox, let's say, to be able to get to that answer. All right, I have now drawn a tape diagram. I know my ratio is 5 to 6. 5 walnuts, 6 cashews. So for my walnuts, I drew a tape diagram split into 5 parts. 1, 2, 3, 4, 5. Because you know your tape diagram is always determined by your ratio. So if there are 6 cashews, then we know that our tape diagrams, we know they line up, right? We want them to be visually lined up so we can see, as best as our artwork will allow us, right? And then it should be a little bit longer because the walnuts, there were 5, cashews, there should be 6. 1, 2, 3, 4, 5, 6. So we're good to go there. We know that the cashews equal 54, because it told us in the problem there are 54. So 54 divided by 6, I know equals 9. So then each of these boxes is worth 9. Going back up here, since the boxes are the same size and we line them up, I know that each of these boxes are also worth 9. So if I add them up, I have 1, 2, 3, 4, 5 9s. So that's 9 5 times, and that would be 45. So my original ratio of 5 walnuts to 6 cashews would be equivalent to 45 walnuts to 54 cashews. Okay, we've gone through a couple of problems here. We're going to look at some more together in class. Thank you for watching, and we'll move on. Good luck.